A quick note on power series solutions. To solve a linear differential equation for y sub x, by the method of power series, we proceed as follows. A, we assume a solution of the form y equals our sum of j equals 0 to infinity of a j x to the j, and B, we substitute y and its derivatives into the differential equation. C, in fact I'm not going to write these A, B and C, so I'm just going to explain it. We've got the only real writing we need here. Well, with B, we substitute this value for y and its derivatives into the equation. And C, we'd express this statement of the differential equation as a power series of x equal to 0 by collecting up all the terms in xj for each j. And D, we use the power series in step C to obtain a reoccurrence relation which can be used to determine the coefficients AJ. And that's the power series. Quick explanation. In fact, I'll go on further here. It's a little bit, I dropped my pen. It's a little bit short, so I'll go do something else. Let's say we want to find out the convergence of the power series. So the power series sigma to infinity 0 aj x minus alpha to the j is convergent at a point x equals x1 if a limit of n goes to infinity of n equals 0 aj x1 minus alpha j exists. And by this definition we mean that the sequence of partial sums SO, S1, S2 ... where Sn equals nj equals 0 of aj x1 minus alpha to the j, in such that Sn tends to some limiting value as n tends to infinity. This value of the proper power series, this is the value of the proper power series at x equals x1. Now for any power series about x equals alpha, there is a radius of convergence such that the power series converges if and diverges if or x minus alpha is less than minus r. The interval alpha minus r x alpha plus r is called the interval of convergence. Now for the convergence theorem we consider a linear homogeneous second order differential equation p of x d squared y dx squared plus q of x dy of dx plus r xy equals 0, where p, x, q, x, r, x are polynomial functions and are all zeros of p of x are real. Any power series solution of this equation about alpha is convergent in an interval minus mu x minus alpha mu, where mu is the minimum distance from point alpha to a point of piece of x, where mu is a lower bound for the radius of convergence R. Right, that's a little bit on power series solutions, power series methods, mathematical methods. Please do like and subscribe. I'll be making plenty more of these, and we'll go through some really good examples too, but this is just a general method of how we go about doing it. Thanks, and please do subscribe.